Okay, so now I want to talk about writing an equation and drawing its graph to model a real-world situation. So let's go ahead and just look at this problem that we have here. The temperature in an oven is rising at a rate of 30 degrees per minute. The temperature started at 70 degrees Fahrenheit. Let T be the temperature in the oven and let M be the number of minutes since the oven was turned on. Write an equation to describe the relationship between T and M and graph it. So let's take a look at what we might be looking at here. So we have these two variables. We have T being the temperature and M being the number of minutes. Now, one thing we want to consider is which one of these is the independent variable and which one is the dependent variable. So an easy way to figure that out is which one depends on the other one. So does the number of minutes depend on the temperature in the oven, or does the temperature in the oven depend on the number of minutes? I think the temperature in the oven depends on the number of minutes since it was turned on. Every time it was turned on, we have a certain number of minutes, and then it gets to a certain temperature. So the minutes happen no matter whether the oven is turned on or not, but the temperature changes based on the minutes. So the independent variable is going to be the minutes, and the dependent variable is the temperature. And we typically graph our independent variable on the horizontal or the x-axis. So we're going to use our x-axis for the minutes, and then we're going to use the y-axis for the temperature. So now let's think about what's actually the relationship between T and M. So if you think about it, temperature starts out as 70 degrees, right? It's 70 degrees when you first turn on that oven. It's 70 degrees. Then for every extra minute, we add 30 degrees. So for 1 extra minute, we add 30 degrees. For 2 extra minutes, we add 60 degrees. For 3 extra minutes, we add 90 degrees, and so on. So if we could actually graph this right now just based on that. So let's go ahead and do that. Let's make this 20, 40, 60, 80, 100, 120, 140, 160. Okay, and this is for temperature here. So it starts out at 70, right? So at 0 minutes, we're at 70. And then at 1 minute, we go up 30 degrees. So we go up 100. And then after 1 more minute, so this is minutes over here, after 1 more minute, we go up 30 more degrees. So when we get to 2 minutes, we are already up to 130 degrees. When we go up another minute, we go up another 30 degrees. So you might start recognizing this. So every time we go over 1, we go up 30, right? So that makes 30 our slope. Or another way of saying that is we add 30 degrees for every minute. We add 30 degrees to the original 70. So every time we add 1 more minute, we add 30 degrees. And so repeated addition, we represent that using multiplication. So 30 plus 30 plus 30 plus 30, every time we have another minute, we can just write that as 30 times M plus 70. So the temperature in this oven should be 30 times the number of minutes plus the original 70 that we had from the start, because it started at 70 degrees. And that is how we would graph this line. Now let me pull out my ruler here, and then I can actually draw that line. So here's our line. And in this case, we can ask ourselves, is there any meaning over here? And really, there's not a whole lot of meaning over here. Negative minutes don't really make any sense, so I should probably go ahead and erase this part right here of my line. I don't really need that. My line really starts at 0 minutes in this case. That's not always going to be the case, but in this case, 0 minutes is the first meaningful minute. -1 minutes doesn't really make any sense. So all in all, my temperature is equal to 30 times the number of minutes plus the original 70. And you can see that this is in the y equals mx plus b form. So that should look pretty familiar. Sorry, you're not able to see that. Let me erase that and make it better. So in the y equals mx plus b format, remember that the y is the independent variable, and in this case, the y is the dependent variable. In this case, so is t. And then the slope in this case is 30 because every time we go over 1, we go up 30. And then x is our independent variable, and so is minutes. And then b is our starting point, or our y-intercept. And in that case, this is 70. And that's how we write an equation and draw its graph to model a real-world situation.